All right, so we're on day 2 today, which your homework for Unit 1, Day 2 is packet page 44. Remember that needs to be uploaded onto Schoology by 5 a.m. tomorrow morning. So I'm guessing most of you will not be up at that time, so make sure you do it this evening and upload it. Remember, tomorrow is an all remote day, so everyone will have a video on Edpuzzle to watch and then homework to do. In our warm-up, we want to be in Tuesday's box, and our goal is to write a recursive formula for this sequence. Recursive formula, remember we always tell first what A1 equals. And then we always do AN equals AN minus 1. And then just tell what the pattern is. Notice these are actually getting larger because they're less negative. So we are adding 3 each time to that. So AN equals A sub n minus 1 plus 3. Now looking at your homework ones, our recursive formulas, you had to tell for each of them what A1 was, then AN equals AN minus 1 and whatever the pattern was. So you had a plus 1, a minus 2, a times a half. Now for the times a half in 14, you could have had divided by 2. And then you have a minus 5 for the 15. And then they wanted you to tell what the next term was. So just continue that pattern once more. So in 12, your next term was 3. Then you had 33, 5/4. You could have also had, instead of 5/4, 1.25. That'd be fine. And then negative 14 in question 15. Our explicit formula for each. So in 20, we're adding 3 each time, so we want to use that arithmetic one. So we have 4 plus n minus 1 times 3. So we have this here. So hopefully you're able to do that part. Now, the second part of this, find A12. If you struggled with that, that's okay, because that's what we're going to practice today. What we do is, if we want A12, since it's an explicit formula, just put 12 in place of n. Fill in 12 for n, punch it in the calculator, you end up getting 37. In 21, we're adding 4 each time. We started with 3, so there's your A1 plus n minus 1 times your d. Hopefully you could do at least that. And then finding A12, just put 12 in for n, put it in your calculator, you get that 47 would be the 12th term. '27 is recursive because it has an AN minus 1. It says start with negative 2, and our pattern is we're just multiplying by 3, negative 3 each time. So we get the negative 2, 6, negative 18, 54, and negative 102. Oh, sorry, negative 162, because we're multiplying by negative 3. And then 28 is explicit, because it does not have the a sub n minus 1. So for our first term, just fill in 1 for n. So negative 4 times 1 squared minus 2, put it in the calculator, get negative 6. And you get your other 4 there, negative 18, negative 38, negative 66, and negative 102. So we want to find the 4th, 5th, 6th, and 7th terms of each of these. So the first one says start with negative 2, and then we're doing the previous term plus 2 first, because that's in the parentheses, and then multiply by negative 3. So here's our previous term of negative 2, plus the 2, which gives us 0, times 3 is 0. And that goes in for the previous term. So 0 plus 2 times 3 gives us 6. Then the 6 goes in for the previous term. So 6 plus 2 times 3 gives us 24. And then just keep doing that pattern. And the ones we actually wanted for our answers were the 4th, 5th, 6th, and 7th, so those ones. Now 47 is explicit because it does not have an a sub n minus 1, so we just directly sub in the terms we want. So sub in 4 to get the 4th of 25, sub in 5 to get the 5th, 36, and then 49 and 64. And that was it for the homework. Again, remember each day, the day that it's due, it's got to be uploaded on Schoology by 5 a.m. That's when I start checking them, because we can't check homework in class this year, and on any given day, some of you are remote. So we're going to be starting on packet page 4. So today's topic is arithmetic sequences and arithmetic means. So we mentioned last class that a sequence is just a list of numbers that follows some type of pattern. Well, arithmetic is when each successive term you get by adding. Now, it could look like you're subtracting because you're adding a negative number, but the technical definition is that you're adding. An arithmetic mean is when you put a number in between that turns it into a pattern that's adding. So for example, if I had 5 blank and then 15, we could make this arithmetic by putting a 10 in between, because then you're just adding 5 each time. Or a basic one, 2 blank 6. What could you put in the middle? So you're adding the same thing every time, 2 4 6. So that the thing we're putting in the blank would be our arithmetic mean. So we'll talk about that at the end of the lesson. So the first two there, we have examples of arithmetic progressions. Now the term progression and sequence can be used interchangeably. So I purposely use them both on this slide just so you start to become comfortable seeing them both. Because on the Regent, a question could refer to it as a sequence or a progression, talking about the same thing. This first one here, notice we're adding 3 each time. This one here, notice we're subtracting 6 each time. And then we have two examples of ones that are not arithmetic progressions. This adds a 5, and then it adds a 7. So that's not adding the same thing every time. This one adds 3 and then adds 6. So that's not arithmetic either. Now the second one there, the bottom right, the 3, 6, 12, is actually a geometric sequence, which we briefly talked about tomorrow, or briefly talked about last class, and we'll look at more in tomorrow's video. But it is not arithmetic because it's not adding the same thing every time. Okay, so consider a recursive formula. It doesn't say it's recursive, but we know it's recursive because it's got the a sub n minus 1. And it's telling us that the a1 is 5. Well, we want to find the second, third, and fourth terms. Well, if a1 is 5, and this is our formula, to find a2, we just do the previous term plus 3 to get 8. And again, this is on the bottom of page 4. To get a3, we just do our previous term plus 3 again. So we get 11. And to get a4, we do our previous term plus 3 again to get 14. Well, the nth term, we kind of talked about this the other day, and it's right from our reference sheet, is an equals a1 plus n minus 1 times d. And your reference sheet doesn't have it, but I always like to put the times d in parentheses just to make sure it's clear it's multiplying, because if d is negative, it might look like subtraction there. And where the n minus 1 is coming from is this 11 was really 5 plus 3 plus 3. So 2 times it happened, which is 1 less than the third term, which we're working with. Okay, moving on to page 5. This is just a snapshot of that reference sheet that you have. Here's our arithmetic sequence formula. And remember, we always want to put that d in parentheses, because it needs to signify that we're multiplying by the d value there. On the bottom, we break down what each of them represents. an is the value of the nth term. a1 is the value of the first term. N is the term number. D is the common difference, which is what you're adding or subtracting by in an arithmetic sequence. So let's say we had 7, 10, 13, 16, 19. In this sequence, the first term, a1, would be 7. D, the common difference, would be positive 3 because we're adding 3 each time. Now to talk about an and n, we want to look at this last term here. N is the term number you're looking at. So that term I boxed, we want to know which term number it is. Well, if we count through, it is the 5th term. So our value of n would be 5. And an is the amount that is in that spot, or the value in that 5th spot, which is 19. So when you're talking n, you should, when you're saying it, have those 2 letters after, th and nd and st, 21st, 33rd, 53rd. That's how you can help identify the n. So if we flip to the next page, page 6, today we're working with all arithmetic sequences, but on the test, it'll be up to you to identify if it's arithmetic or geometric. So let's imagine we didn't know that today was an arithmetic day. We could look at this and you might be able to just recognize that we're adding 0.3 each time. So that means that our D is 0.3. Now, if you cannot just look at it and see that, which sometimes with decimal ones it'll be hard to, is the opposite of adding is subtracting. So you just do the second minus the first. So D would equal 2.6 minus 2.3, and that's where we could get the 0.3 from. So because we're adding 0.3 each time, that tells us we have arithmetic. So we would go to our reference sheet. Again, don't forget the plus. For some reason, lots of people forget the plus. A1 plus n minus 1 times D. We would want to find the 95th term. Now the technical notation for that is you would write A95. That means we are working with the 95th term, and we're finding the value of it. Our A1 here is 2.3 plus parentheses our n that we're working with, our term number is 95, and then the D, what we're adding each time was 0.3. So from here, all we would do is punch the entire right side in the calculator. And when we do that, we get that the 95th term is 30.5. Now always see if your answer is reasonable. Our three terms we have there are going up. So we know our answer has to be something bigger than 2.9. If you got an answer less than 2.9, you know that you did it wrong. We got something bigger than 2.9, so it seems like our answer could be reasonable. Going down to the bottom, we're going to find the 72nd term. Let's see what our pattern is. We're subtracting 3 each time, so that tells us arithmetic. So our D is -3. If we couldn't just look at that and see it, we would do A2 minus A1. So we would have done 5 minus 8 to give us that -3. So our arithmetic formula from our reference sheet is A1 plus n minus 1 times D. We're finding our 72nd term. A1 is 8 plus 72 minus 1 times our D of -3. When we punch that all in the calculator, we'll get -205. Now, notice our numbers are getting smaller each time. So if you don't get something smaller than -1, you know you did it wrong. What that often catches is an error where you have the wrong sign. If you had put 3 in for D, you would have gotten something bigger than -1 and you would know that you are off. So that's why you want to at least think about your answer each time and whether it makes sense. Going to the top of page 7 now. We have our 60th term is 572. Common difference is 1.7. Find the first term. Now they told us it's arithmetic. So we will use that formula. We want to find the first term. So we don't know A1, meaning we should be able to fill in for everything else. The value of the term we're working with is our AN. So that's the 572. N is the spot number, so 60. And then our D, they said, was 1.7. And now we'll just do a little equation solving. If we type in that part to our calculator, we'll get 100.3. We can subtract that 100.3 over. And that would tell us that A1 is 471.7. Well, now they want us to find the 32nd term. So our notation we would use is A32. Our first term we now know is 471.7 plus 32 minus 1, because we're doing the 32nd term, and our d we knew from before was 1.7. So if we put that all in the calculator, it would end up giving us 524.4. Now when you put in the calculator, it's important to make sure you have your parentheses and all the correct spots and everything. All right, in an arithmetic sequence. So we know we're dealing with our an equals a1 plus n minus 1 times d. They tell us a1, they tell us d. Which term is negative 80? So we need to know, is it the third term, the fifth term, the 70th term? Well, whatever has that little th or st after it, that's always the n. So we don't know the n, meaning we should know everything else, meaning the an is negative 80. We'll fill in our a1. Now there's a couple ways we could solve this. What most people tend to like to do is to distribute the negative 2. So that'll give us negative 2n plus 2. Because you can distribute a number that's behind or in front. Usually we see it in front, it just happens to be behind here. So that'd be negative 80. If we combine like terms, that'd be 12 minus 2n. We could subtract the 12 to both sides. And that would give us negative 92 equals negative 2n. And we could divide by negative 2 to give us n equals 46. So that tells us the 46th spot would have the negative 80 in it. How many terms are in this sequence below? Well, again, that's saying how many spots there are. So we're just trying to find the n again. So 29 is the value of that spot we're looking for. A1 is 5, and our d is just 0.8. I'm going to show this one how you could solve it the other way. What you could do is you could subtract the 5 over first. And then instead of distributing the 0.8, the opposite of multiplying by 0.8 is dividing by 0.8. When you do that, we'll end up getting 30 equals the n minus 1. Add the 1 over, you get n equals 31, meaning the 29 must be in the 31st spot. All right, we're going to skip the next one, and we're going to go to the top of page 9 and finish off by looking at arithmetic means. Well, if you want to insert an arithmetic mean, however many you want to insert, you want to put blanks in between those numbers. So we want to insert one arithmetic mean, so we'll put one blank there. We're going to think of that as A1, this is A2, and this is A3. Now labeling it like that, from our formula, the things we know our A1 is negative 7. Looking at our last term, its value, AN, is 11, and our n value must be 3. So filling into our arithmetic sequence formula, that would give us 11 equals negative 7 plus 3 minus 1 times d. So we don't know d, but if we can figure it out, that'll tell us what we add each time, and then could allow us to identify what goes in the blank. So we'll start by adding the 7 over. So we get 18 equals, I'm going to neaten this up because it'll save us a step. So 3 minus 1 is just 2d. And if you divide by 2, we just get 9 is equal to d. So this is saying each time we should just add 9. So we're going to add 9 here. Negative 7 plus 9 will give us 2. So that's our answer. But to check it, just add 9 again and see if it works out. 2 plus 9 does in fact give us 11. So that means we are in good shape. And our last one we'll look at is an example of inserting 2 arithmetic means. So that's why there's 2 blanks there. We want 2 arithmetic means. So we'll call that one A1, A2, A3, and A4. So our things we know is A1 is negative 4. And then looking at this spot, our AN, the value of the spot is 20. And the term it is, the spot number is 4. So if we fill in what we know, the AN is 20, A1 is negative 4, we'll have 4 minus 1 times D. We can add the 4 over to give us 24 equals, that'll become 3D when we do 4 minus 1. And if we divide both sides by 3, we will get D equals 8. Now just note, that's not your final answer. That just tells you what you add on each time. So we're going to add on 8 to the negative 4 to get 4. We'll add on 8 again to get 12. So these are your answers, but add on 8 once more. 12 plus 8 does give you 20, so that's a check to make sure you did it correctly. So we're going to stop there for this lesson. Your homework for tonight, you have packet page 44. Remember, that needs to be uploaded to Schoology by 5 a.m. tomorrow morning. You can do it on a separate sheet of paper, or you can just do it right in your packet and take a picture of it. Okay, remember to use your reference sheet as you are doing it.